Hey guys, welcome to another fun session on not just solving but understanding problems. The objective of this session is very important to understand in the very beginning. So the objective is to do a thorough analysis of problems. People usually are in the habit of throwing the problem to the graveyard as soon as they reach the answer. So that is a basic human tendency. But through this video we would like to demonstrate a very important thing. So we would like to show that reaching the answer is just the beginning of learning and not necessarily the end. So let's get started. So we'll take up a very important and interesting and easy puzzle today. So in popular culture, this puzzle has occurred in the movie Die Hard 3, wherein Bruce Willis is confronted with the problem of some jars, playing with the jars, and to disarm a bomb.
Be careful. Don't open it.
What? I gotta open it. It's gonna be all right.
I told you not to open it.
I trust you see the message. It has a proximity circuit, so please don't run.
Yeah, I got it. We're not gonna run. How we turn this thing off?
On the fountain there should be 2 jugs. Do you see them? A 5-gallon and a 3-gallon. Fill one of the jugs with exactly 4 gallons of water and place it on the scale, and the timer will stop. You must be precise. 1 ounce or more or less will result in detonation. If you're still alive in 5 minutes, we'll speak
Wait
again.
a sec! I don't get it. You get it?
No.
Get the jugs. Obviously, we can't fill the 3-gallon jug with 4 gallons of water, right?
Obviously.
All right, I know. There we go. We fill the 3-gallon jug exactly to the top, right?
Uh-huh.
Okay, now, we pour that 3 gallons into the 5-gallon jug, giving us exactly 3 gallons in the 5-gallon jug, right?
Right.
Okay.
Then what?
Now, take the 3-gallon jug, we fill that a third of the way up.
No, he said be precise. Exactly 4 gallons.
Copping 50 miles is running his ass off, and I'm out here playing kids' games in the park.
Hey! You want to focus on the problem at hand? We got less than a minute. Throw this thing away.
Look, we can't take it off of it. It'll detonate. Just wait a second, wait a second. I got it. Exactly 2 gallons in here, right?
Right.
Leaving exactly 1 gallon of empty space, right?
Yeah.
A full 5 gallons here, right?
Right.
You pour 1 gallon out of 5 gallons into there, we have exactly 4 gallons in there.
Yes.
Pour it in there, come on. Come on. Don't spill it. Good. Exactly 4 gallons.
You did it, McLean.
Put it on the thing, get it down there.
Congratulations, you're still alive.
So let's see a formal statement of the question. So there are 2 jars, one of 3 liter and the other of 5 liters capacity, and we need to measure 4 liters using them. So we have also been given an infinite supply of water since we are standing in front of an ocean. Now how do we do this? Please note that the implicit information available in the question is that there are only 2 kinds of operations that we can perform on these jars, using these jars and the water. So the 2 atomic operations are either completely filling any of the jars and stopping immediately, or completely emptying any of the jars and stopping immediately. So these are the 2 basic steps. Now how do we proceed with the solution? So viewers are encouraged to pause this video immediately and think of a solution before moving ahead. So here's a hint. This problem can easily be solved by hit and trial. So even if you keep struggling with the problem, you'll reach the answer in some time. Now moving ahead with the solution. So this is the solution to the problem. So let's try to visualize it a bit. So let's iterate the contents of the table one by one. Let's call the bigger jar as A and the 3 liter jar as B. So first we fill the jar A up to the brim. Then we pour 3 liters from A to B. we are left with 2 liters in A. Then we empty the jar B. Then we pour 2 liters from A to B. Then we fill the jar A again. Then we pour 1 liter from the jar A to B. By this time the jar B gets filled up to the brim and we are left with 4 liters in jar A, which was the required amount. Now the reason we have made this video would be clear in a while. So most of the people drop the problem here itself. We had been given a question, we have solved it, and we just drop the question immediately. We do not think further. But let me ask you a very simple question. Have we got a complete understanding of the problem? Sure about that? Okay. So let us try this one. Can we do this one? So here are the two jars once again. This time I have put some two vaguely random numbers as the capacities of the two jars. So the one jar measures 15,321 liters and the other one measures 69,002 liters. And using these two jars as well as the ocean, we need to measure 493 liters eventually. So now can you handle this? You are encouraged to pause the video and try this question for 2-3 minutes before moving ahead. It is also imperative to note that the struggle to find a solution helps us evolve to become better problem solvers. So let's just forget about the answer for a moment and just give the question a genuine try. So those who have solved this problem, really well done. But those who haven't, there is an important lesson for you to take away from here. Before we get on to the solution, we'll first talk about the significance of generating test cases. Test cases help us explore every nook and cranny of the problem. So if I think about this kind of a problem, the test cases that come to my mind would be, say, instead of 3 and 5, let me take 1 and 3 liters, or maybe 3 and 6 liters capacity, or maybe 6 and 8 liters. So let's try some of them. So test case 1. Let's say one of the container is of 6 liters and the other is of 8 liters capacity, and we need to measure 4 liters using them. So how do we proceed? Please give it a try. So discussing the solution. So let's call the 8 liter jar as A and the 6 liter jar as B. We'll fill A up to the brim. Then we'll transfer 6 liters from A to B. We would be left with 2 liters in jar A. Then we would empty jar B and then we would transfer the 2 liters of A to B. Then we would fill jar A. Then we finally transfer 4 liters from A to B. B gets filled up to the brim and we are left with 4 liters in A, which is the required answer. So this problem, although a very easy one, gives us an insight into the concept. So here we can observe that this test case had a difference in capacities as 2 liters, 8 minus 6, which is a factor of 4. Thus we can intuitively observe that the difference in capacity, if is a factor of the required amount, it becomes very convenient for us to come up with the procedure or the steps for the answer. So based on this insight, let us try one more test case. This time we have two jars, one of 3 liters and the other of 6 liters capacity, and we have to measure 4 liters. How can we do this? Pause the video and try it out. Okay, so while solving the problem, you would have easily observed that the solution can only occur in multiples of 3, namely 0, 3, 6 and 9. So this also gives us another insight into the problem. So it says that if there is a common factor C between the capacities A and B, we can only have multiples of C. So using the intuition generated from the test cases 1 and 2, we can conclude that in order to get difference of multiples of A and B, we can formulate it as a mathematical equation, a linear equation, Ax minus By equal to n, where A and B are the capacities of the jars and n is the required output. So applying this equation on our previous test cases, on test case 1, if we take 2 common on the left hand side and try to solve it, we would get 4x minus 3y equal to 2. This would give integral solutions at the values 2 and 2 for x and y. So these 2 and 2 represent the number of steps taken for filling or emptying the jars. So trying it on test case 2, we get 2x minus y equal to 4 by 3. Now this gives us a fraction. So at least one of the values out of x and y would be fractional, thus giving us non-integral solutions. But wait, the number of fillings or the steps taken should always be integral. Thus we would not get any solution in this case, which is rightly implied. So the final rule that comes out to be is the equation ax minus by equal to n has a solution if and only if the GCD is the greatest common divisor or the highest common factor. So the GCD of a and b is a factor of n. Only then we can get a solution to this equation. So there is some good news for you. Now we are completely equipped to solve the scary figure problem posed earlier. So the problem said that there are two jars, one of 15,321 liters and the other of 69,002 liters, and we need to measure 493 liters using them. So if we formulate into an equation and later try to compute the GCD, we would get the GCD of 69,002 and 15,321 as 1. So since 1 is a factor of 493, the solution definitely exists. So finally we have solved the problem. The problem showcases our methodology of learning. We call it the BrainGym methodology. So the core takeaway from this idea is that we should keep trying the problem. We should try to generate multiple test cases. We should analyze the problem, dissect it. We should also keep struggling with the problem till we get a mathematical solution. So a mathematical solution is the most robust one. It's like a mathematical solution helps us scale the problem. So from 3 and 5 we have gone to some much bigger values like 15,000 and 69,000, something like that. Also a mathematical solution helps us relate with other problems. So this problem could be similar to a lot of problems which use linear equations. So we can relate those problems. Apart from that, a mathematical solution also helps us convert it into an algorithm. So now as the values of the capacities go higher and higher, we would not be able to do these things manually. So we need to automate this. In order to automate that, we need to convert the solution to an algorithm so that we can feed it to a computer. So in order to be able to do that, we should have a mathematical basis by which we can convert it into some code or logic. That is where maths comes into play. So this is not the end. This is still not the end. So curious people can explore some other problems also. So we have not covered a formal proof of the final rule that we got. Ax minus by equal to n has an integer solution if and only if the GCD of a and b divides n. Also, one can explore the number of different ways in which we can achieve 4 liter using 3 liter and 5 liter jars. So we have talked about the steps to do it, but the number of different ways in which we can reach the solution has not been covered. Also, how to make a computer do this task. Say for example, checking if a solution exists or generating every step of the solution automatically. So guys, if you like the idea of not just solving but completely understanding problems, please like, comment and share and subscribe our channel. So our channel is QOE, our FB page is www.facebook.com/quantumofexcellence and the site is www.qoe.co.in. Thanks for watching.